Assalamu alaikum students. Hope all of you are fine by the grace of Almighty Allah. Welcome to our today's chemistry class. In this video, I will discuss about the limiting reactant, which is also can be called limiting reagent. And this is reactants, and that means it's about chemical reaction. And but For better understanding, I will start with comparing a chemical reaction with a cooking recipe. And our today's lesson about limiting reactant and the recipe. Suppose you want to make a some cup of tea, and then you need it for making a cup of tea, a tea, one tea bag and 1 teaspoon of sugar. Okay, this is the recipe for making a cup of tea. And but we have 4 tea bags and 7 teaspoon sugar. And so, how many cup of tea you can make? At first, consider our first ingredient, which is 4 tea bags. 4 tea bags can make 4 cup of tea with 4 teaspoon sugar. Okay, and if we consider seven, our second ingredient, 7 teaspoon of sugar, then 7 teaspoon sugar can make 7 cup of tea with 7 tea bags. Okay, but look at these two facts. Okay, these two condition. At first, 4 tea bag and 4 tea bag and 4 teaspoon sugar can make 4 cup of tea. Okay, and these 4 teaspoon sugar are available in our ingredients. Okay, we can take 4 teaspoon sugar from our ingredients, but for second case, 7 for making 7 cup of tea, our sugar is available 7 teaspoon sugar, but 7 tea bag are not available in our ingredients. Okay, that means we don't have 7 tea bags. That means this 7 cup of tea, making 7 cup of tea is not possible. Only 4 cup of tea can be made. Then that means between these two ingredients, our two ingredients, these ingredients, that means tea bags, are finished first. And these finished ingredients give us the concept of limiting reactant. Okay, for this recipe, this 4 tea bag, that means tea bag is the limiting reactant. And then we can define limiting reactant as limiting reactant is the first reactant that is used up in a reaction, and when the limiting reactant is all used up, no more product can form and the reaction stop. Okay, and we call it limiting reactant because it limits how much the product we can make. It does not matter if we have 100 spoon of sugar. Once we run out of these 4 tea bags, we cannot make any more cup of tea. So the total number of cup of tea that we can make is completely dependent on our limiting reactant. That means only totally dependent on our 4 tea bags, which is our limiting reactant. And after finishing the tea bag, we still have some extra sugar. Okay, we only use 4 teaspoons of sugar, and we still have some extra teaspoon of sugar, and uh, this extra sugar left over in our reaction ingredients, and this is known as excess reactant. Excess reactant is what is left over after the reaction stops because the limiting reactant got all used up. And in that case, we have some extra reactant, and if we and which is 7 minus 4, that means 3 teaspoon of sugar. Okay, and using this using this limiting reactant, we get this product. Okay, using 4 tea bags, we get 4 cup of tea, and this amount of product is known as theoretical yield. Is known as theoretical yield, and that means theoretical yield is whatever the limiting reactant actually produces. Okay, and between these two, if we compare these two products, then you can easily observe that limiting reactant produces the least amount of product. Limiting reactant produces the least amount of product. 4 cup of tea is less than 7 cup of tea. Okay, and uh, now uh, uh, we can apply this concept in chemistry. Look at the real reaction, and this is a problem. Uh, let's try to solve this problem using this limiting reactant concept. Okay, and 75-gram chlorine gas is mixed with 5-gram hydrogen gas, which is the limiting reactant here, and how much of which reactant will be left over at the end of the reaction. And the next requirements is what will be the theoretical yield of HCl, which is our product. Okay, and or calculate the amount of product in the reactant. The amount of product is the theoretical yield. Okay, and then at first we have to write for any stoichiometrical to solve any stoichiometrical problem. um, at first we have to write the chemical equation. Okay, the chemical equation is hydrogen plus chlorine, and the product is HCl. And now we have to balance the reaction. And if we put 2 in front of HCl, then the equation is balanced because here hydrogen in one hydrogen molecule, 2 hydrogen atom is present, and also in chlorine molecule 2 chlorine atom is present, and this is our balanced equation. Now we have to calculate the mass. We have to calculate the mass of each chemical substances which are used in this chemical reaction using their atomic mass. Okay, and this is right below here. 2 gram hydrogen, chlorine 2 into 35.5, the atomic mass of chlorine, and which is 71 gram, and then 73 gram HCl. And now we have to calculate how many hydrogen, how much hydrogen we apply here the gram to gram conversion method. That's why we use the gram amount. Okay, and now we have to see that how much one reactant reacts with how much other reactant and produce our product. Okay, how and that means how much hydrogen could react with how much chlorine. We have to calculate that at first. Okay, and we start with any from any reactant. We start with hydrogen or we start with chlorine. Okay, but at first we will start with hydrogen. Okay, 2 gram hydrogen. From this balanced equation we can easily observe that 2 gram hydrogen gas reacts with 2 gram chlorine in this reaction and produce HCl. Okay, and our given amount is 35 gram chlorine gas and 5 gram hydrogen gas. So we use 5 gram hydrogen gas. That means 5 gram hydrogen needs 71 into 5 by 2 gram chlorine in the reaction, and the amount is 177.5 gram chlorine in the reaction. Okay, we get the amount uh, which is needed to react with 5 gram hydrogen gas to produce HCl. Okay, but here we can see we have only 75 gram chlorine gas. Okay, and to react completely react with 5 gram hydrogen gas we need 177.5 gram chlorine. That's why this 75 gram chlorine is our limiting reactant. That means chlorine is our limiting reactant. Okay, that means this chlorine will run out earlier. Okay, will finished at first. Okay, at first chlorine gas will be finished, and that's why it is our limiting reactant. Okay, and once we identify the limiting reactant, we just use data for that substance to calculate how much product we will get. Okay, and since that substance will get used up, okay, completely used up, if we use the other one, that means if we use the hydrogen for that reaction, then we would get the wrong answer. Okay, because not all the reagent in excess will go towards generating product. Okay, okay, this is our excess reactant, and these are not involved in this reaction to produce our product. Okay, our production is totally dependent on the limiting reactant, the amount of limiting reactant. Okay, and we can see the other option. Okay, if we start with chlorine, let's see, this is our reaction, and this is our given amount of hydrogen and chlorine, and if we start with chlorine, 71 gram chlorine needs 2 gram hydrogen in the reaction, and so our given amount is 75 gram chlorine. 75 gram chlorine needs how much hydrogen, okay, to produce HCl, and we get 2.1 gram hydrogen in the reaction. Okay, okay, and we have 5 gram hydrogen. That means uh, this 5 gram is much more than enough. Okay, and that means this chlorine is our excess reactant, and how much our next question is our next question was the requirements was how much of which reactant will be left over at the end of the reaction. So we can easily now uh, calculate this uh, excess amount of reactant by using this formula. Excess amount left over is equal to original amount, that means our taken amount, and taken amount which is 5 gram hydrogen, and the amount used which is 2.1 gram. Okay, and this amount is 2.9 gram hydrogen. Okay, that means the hydrogen which reactant, that means hydrogen gas is the reactant which will be left over, and the amount of leftover, the extra amount of reactant is 2.9 gram hydrogen. Okay, and our next question is what will be the theoretical yield of HCl? Okay, and that means what will be the maximum amount of product in the reaction. Okay, and we know our maximum product depends on totally depends on the amount of limiting reactant. So uh, we use the amount of limiting reactant for calculating the amount of product. Okay, and now we have to calculate this amount of product by this way, using this way, and 71 gram chlorine, this is our limiting reactant. 71 gram chlorine produces 73 HCl in the reactant from our balanced equation, from our stoichiometry. And now we have 75 gram chlorine, given amount produces how much amount of HCl. And this is 77.1 gram HCl in the reactant. And this is our theoretical yield. Okay, this is our theoretical yield, and this is our amount of product. This is our amount of maximum product. I think this concept is clear to you, and very important, very important, and comparatively a complicated concept in this chapter. Okay, so of this chapter, and if you practice, then it will be more easier to you and more clear to you. Okay. Another related important, very important concept is percent yield. Another real life limitation of chemistry is that when we are working in a lab or do a chemical reaction and want to get the amount of yield which is equal to theoretical yield, but we never get the amount of product which is equal to theoretical yield. Uh, uh, because the chemical substances, the reactants, that means the reactants used in the chemical reaction are not always 100% pure. And the purest chemical substances or reactants, which are 99% pure, is called annular or analogate. That means the chemical reactants are can be maximum 99% pure, and which is called they are known as annular or annular grade. And when the reactant is not 100% pure, the reaction does not yield the amount of product that is calculated from the amount of limiting reactants. That means that is our theoretical yield. And the theoretical, the amount of product which is equal to theoretical yield, we can just expect if the every molecules of reactants converts into products, only then it is possible. But actually in reality this does not occur, and the actual yield is always some fraction of theoretical yield. and which is known as percentage of yield or percent yield. That means the actual yield always be be some fraction of theoretical yield, which called the percent yield. And the percent yield is actual yield over theoretical yield times 100. Okay, the actual yield over theoretical yield times 100 is known as percent yield. And that means the actual yield means amount of product obtained from reaction, and theoretical yield we know calculated amount of product from the reaction balanced from balanced equation, and then multiplied by 100 and we get percent yield. And we can and observe an problem, and our previous, if we add with our previous uh, previous problem, which we have just right now solved. This is, if the actual yield is 73.5 gram, what is the percent yield? Okay, and that means the actual, look at this formula, the actual yield is 33.5, and from our previous problem we get the theoretical value was, the theoretical yield was 77.1. Okay, try to remember, this was 77.1, and if we put these two amount in this formula, then we can easily calculate the percent yield. And the actual yield is given 73.5, and 77.1 is theoretical yield, and then multiplied by 100 and we get 95.33% yield. And this is the reality, and this is a very important concept, for a very useful concept for planning in industrial chemistry. Okay, and for production of any substance, any chemical substance, this is a very important concept. We have to calculate the percentage of yield. And this was our today's lesson, and that's all for today. Assalamu alaikum, students.